2.1, the first lesson of Unit 2. And if you're following along in the textbook, it's actually pages 89 and 90. And you'll see it's actually 2.4. So the textbook lesson and our lesson numbers aren't going to align anymore because we skipped a few lessons in Unit 2 from the textbook. So this lesson has a lot to do with postulates, and we've sort of talked about these before, but now Unit 2 is called reasoning and proof. And mainly what we're going to do here is step away from definitions and really think about what reasons or what do we already know that we can use if we're trying to prove or show something. And what some of the reasons that you'll definitely use are postulates. So remember, postulates are things that do not need to be proven. They are proven just by their existence. So the 4 postulates we studied in Unit 1, mainly 2 and 4, but we touched on 1 and 3. Segment addition, angle addition, ruler, and protractor postulate. I don't think I ever actually talked about this, but it's similar to the ruler postulate in that the size of an angle, or how big an angle is, can be measured using a protractor. And you can do that by starting at 0 and looking at where the side or the ray crosses the protractor. So, and that is the size of the angle. It's pretty much what the protractor postulate says. Like if you measured an angle and it was 30 degrees, you wouldn't need any other proof. It's just the measurement is the proof. Okay. So postulate 5, we've also kind of talked about this. Through any 2 points, there exists only one line. So through any 2 points, you only have one line. So my diagram, if I was to represent this, I would say the word if and draw 2 points, because this is sort of my condition. This is what has to exist in order for me to make the conclusion that there's only one line. So the then is our conclusion. So if I start with 2 points, if that condition exists, then the conclusion I can make is there only exists one line that goes through them. So here is the hypothesis, conclusion. So if this is true, then I can conclude that. Okay. A line contains, and you can also think of, instead of hypothesis, you can think of this as a condition. A line contains at least 2 points. So these two actually sound really similar, but it's really what my condition that I'm starting with is. And in this case, I'm starting with a line. So a line, so if I have a line, then I can conclude that that line has exactly 2 points. At least 2 points. Not exactly, at least. So 5 and 6 are close, but really our condition, what we're starting with, is different. 7. If 2 lines intersect, then their intersection is exactly 1 point. So we definitely talked about this in Unit 1, is if you have 2 lines that cross, their intersection is exactly 1 point. So they cross at point B. Okay. 8. Through any 3 non-collinear points, there exists only one plane. So if I have 3 non-collinear points, then I can only draw one plane that would contain these points. Postulate 9. A plane contains at least 3 non-collinear points. So kind of like these two again are kind of related to each other. But I'm starting with the plane. So if I have a plane, then I can say this plane has at least 3 non-collinear points. Now, these numberings match the numbering in the lesson in your textbook, but again, postulate 5 is not postulate 5 in every textbook. But I'm going to keep these numberings and refer to them in this lesson. In a plane, then the line containing them also lies in a plane. So if I have 2 points that lie in a plane, then the line containing them that was a really bad line, but the line containing them also is part of the plane, right? And if 2 planes intersect, then their intersection is a line. All right. So here's 2 planes. Ooh. All right. So here's 2 planes, and where they cross all along this line. So we sort of talked about 10 and 11 in Unit 1. So what does this look like? I can ask you to identify the postulate. Now, you don't have to memorize these postulates. This will almost always be multiple choice or matching. So you don't have to memorize them in terms of like writing them out, but you absolutely need to be able to identify them. So if that line exists, then there's 2 points on the line. So if you go back to our list here, we know, okay, it's points and a line. It has to do with 5 and 6. Now, how do I know which one it is? Well, it depends on what you're starting with. If you look at that first example, we're starting with a line, and if that line exists, then we have 2 points on that line. So this is actually postulate number 6, or a line contains at least 2 points. Okay. Now, second example, if I have a plane, then there's 3 non-collinear points in that plane. So this, again, very similar. Is it 8 or 9? Look at what we start with. We start with a plane. So this one is a plane contains at least 3 points. Now you can try these on your own and then check your answer, or you can continue to listen. Now, this is sort of the inverse of this. So now I'm starting with the 3 points. So this would be actually postulate 8, which says through any 3 non-collinear points, there exists only one plane. Now this one, if I have 2 points in a plane, that's how I would read this, then the line that contains these 2 points also lies in the plane. So that's postulate 10. I'm just going to put 10 here. But that's postulate 10. If you scroll up, says if 2 points lie in a plane, then the line containing them also lies in the plane. All right. Now, I can also ask you to identify a postulate from the diagram. So use the diagram and state the postulate that verifies the statements. The first statement is points E, F, and H lie in a plane, and they're talking about plane R. So which postulate is it? Well, what did we start with? Was a condition that the points had to exist or that the plane had to exist? It's the points. So this would actually be postulate 8. That if you scroll up, it says, through any 3 non-collinear points, there exists only one plane. Now, if I wanted to use postulate 9 for this, I would actually rewrite this to say plane R contains points E, F, and H. So if I wrote it like this, then this would be postulate 9, which is a plane contains at least 3 non-collinear points. But I started with the points, so this would be postulate 8. Now, points E and F lie on a line, which is labeled M. So, again, did I start with the points or did I start with the line? I started with the points. So this would actually be postulate 5, which says, through any 2 points, there exists only one line. If I wanted to use postulate 6, a line contains at least 2 points, I would have to start with line M. So I would say line M contains points E and F. So you got to just look at what they're starting with, or what the statement is starting with, or what you're given first. The planes Q and R intersect in a line. This one's kind of simple because there's only one postulate that deals with this. It's the last one, postulate 11, which states 2 planes intersect in a line. And then finally, the fourth statement. And you can see here planes Q and R. Plane R is already highlighted in yellow. Plane Q is right here. And where they both cross is along this line. Okay. Now, last one. Points E and F lie in plane R. Therefore, line M lies in plane R. So this one is postulate 10. Which says if 2 points lie in a plane, then the line containing them also lies in a plane. Perpendicular figures. Only assume a line is perpendicular to another line or a plane if it is stated or marked with a right angle symbol on the diagram. Okay, so perpendicular, which is this symbol here, represented by this symbol here, means that if 2 lines or planes are perpendicular, they're crossing at 90 degrees. So you'll see it, either they'll tell you verbally using the word perpendicular, or they'll have this symbol here, the right angle symbol. So that means these 2 lines intersect at 90 degrees. If you don't see this or this word, no matter how straight those lines look, you cannot assume that they cross at 90 degrees. Okay, and that's what's getting to us here, is that when you're given a diagram, there's certain things you can assume and there's certain things we cannot assume from a diagram. This actually goes with that. All right. So in this picture here, or in this diagram here, what can I assume? And I'll never ask you to do this, but it's always like, we'll do this more so in class when we're trying to write a proof, but this is also just I think the cannot assume is important to understand here. Now, what we can assume is all points are coplanar. And I can assume this because I don't see any points off of the plane. So all the points that are on this diagram are contained within the plane. Now, I can assume points A, H, J, and D are collinear. They're on a straight line. A, H, J, and D right here. Points A, there's H, there's J, there's D. They are collinear. Now, I can also assume angle AHB, which is right here, and BHD, which is right here, are a linear pair. And they are because they are on a straight line. So angle AHB, which is right here in the yellow, this angle right here, and BHD on the other side form a linear pair. Another thing you can assume is line AD and line BF cross at point H. So line AD is the one where I marked those points, A, H, J, and D. So that line. And line BF is right here in the blue now. So they both cross at point H. Okay. Some things we cannot assume here. We can't assume that line BF and CE will intersect. So line CE is right here, and BE is in, or BF is in the light blue here. So we can't assume that these two will cross. We cannot make that assumption. No matter, even if CE was sort of like more like this, and well, kind of they will eventually cross, we still cannot make that assumption. We also can't make the assumption that they will not cross. So and in the next unit, we'll see two lines will not intersect if they're parallel. So what this is saying is you can't make any assumptions about line BF and CE in terms of if they're parallel, they won't cross. If they're not parallel, they will cross. You just don't know. You don't know. There's not enough information here. And you can't assume line AD is perpendicular to BF or line AD is perpendicular to CE. Okay? Can't make those assumptions. All right. The last piece here. B, C, and D are collinear. I think in Unit 1 I said points don't actually have to be in a straight line to be collinear. There are some, as long as they look like a line can be drawn through them. This textbook, the textbook that I used in my previous years said that, but this one actually is saying that you cannot assume. So this is false or no, you cannot assume it. So unless there's actually a line, you can't assume points are collinear, okay? And I know what I said in Unit 1. We're just going to go with this just to keep it consistent. So B, C, and D, even though they look like a line can be drawn through them, there isn't a line drawn through them. So no, you cannot assume they're collinear. AC, line AC, again, this means perpendicular or will cross BE at 90 degrees. No, I cannot make that assumption because I don't have the symbol, or there's nothing in the diagram that tells me that they cross at 90 degrees. Now, angle CFE and angle AFE. Whoops, that was actually the wrong angle. Hang on. So angle CFE. No, that was right there. CFE, this angle. And angle AFE, which is right here, AFE, form a linear pair. And this is true. Because you don't need the postulate, like AF and BE are lines, and linear pairs are formed by intersecting lines. So you don't need any other marking, or they don't need to, the diagram doesn't need to give you any additional information for you to assume that these are a linear pair. These are a linear pair, these two angles. They are supplementary. They're on a straight line. Now, CFE and AFE are congruent. That I cannot assume. So this is sort of saying that if they are congruent and they're on a straight line, this is saying, can you assume that each of them are 90 degrees? No, you cannot. Now, I can easily change that by just adding, this symbol right here. So if I gave you the little 90-degree symbol, this would actually be true, because if this is 90, this is 90. All the angles around this point would be 90, and this would actually be true. But that's not the case here. Okay. All right. Sketch the diagrams, and this is kind of what we're going to do in class on Thursday. Sketch the diagram using the given information. So if you essentially draw a picture that would represent this, I have line AB, and I have BC, and they are perpendiculars. That means they cross at 90. Whoa. Okay. And they actually intersect at 90 degrees. Okay, and you don't have to add all of these symbols. You can just add one. If you add, oops. If you add one little symbol here, that's enough. That means they cross at 90. Sketch a diagram showing TV intersecting PQ at point W so that TW and WV are congruent. Okay, so this is a lot. Sketch a diagram showing TV intersecting PQ at point W. So I'm going to draw TV first. And there's another line PQ that's intersecting TB, or the lines are crossing at point W. But point W, I can't put point W anywhere on this because I need to put point W exactly in the middle, because I need TW and WV to be congruent. So if W is exactly in the middle of TB, then I can say that TW and WV are congruent, and W is the point at which PQ intersects TB. So this is the point through which PQ crosses TB at point W, such that it's cutting TB in half. So actually, PQ in this case is a segment bisector, or line bisector, whatever it is. But because it's cutting TB in half.